Has this ever happened to you?
Hello?
10 minutes before the cookout and the phone rings. And you find out that there are 3 more people that are going to show
How
up.
many more are coming?
Now, do you call these people back and find out exactly how much food they're going to eat? Or is this a time when you make an estimate? When you say, well, each person will have 2 hot dogs and a few marshmallows. So you go to the store and you buy another package of hot dogs. Well, that is exactly what it is. This is when we estimate, when we don't need an exact answer. We didn't need to know exactly how much they were going to eat, just an approximate result. We do the same thing when we plan a trip. We go to our road map and find out how far it is from one city to the next so that we can get an idea of about how long it's going to take us. We didn't need an exact answer here, so we used estimation. Another time we estimate is when an exact answer is not possible. An example of this might be the number of gallons of water in a city reservoir. Now, the amount of water in the reservoir is important, but the exact amount of water is not. So we would estimate how much water is there in order to fulfill the city's needs. A third time when we estimate is when we use the calculator. We know the calculator gives us an exact answer. However, we're never quite sure if we're correct unless we estimate. If we make a good estimate of our answer and then we look at the exact answer from the calculator and the exact answer and our estimate are close, then we know that we've used our calculator correctly. So you see, we've seen 3 examples of when you estimate. You estimate when you do not need an exact answer, like we did with the barbecue question. You estimate when you cannot find an exact answer, like we did with the reservoir question. And you estimate when you use your calculator so that you can be sure that the answer that you received is a reasonable answer. Now, I bet that you can think of some examples when you estimate when you don't need an exact answer, or perhaps when an exact answer cannot be found. What examples can you think of? This is a situation that we find ourselves in almost every day. We've arrived at a store or a restaurant, and we want to know, do we have enough money to cover whatever the charge might be? Do we need to know exactly how much money it costs to buy all the food or buy whatever we're buying? Well, the answer to that is no. We just need to have a good, useful guess for how much money to have with us. Similar to this kind of question, if I was to ask you which one of these cards had more dots on them, I'm sure that very quickly you recognized that this was the correct answer to that. Well, did you count the number of dots exactly? Well, the answer to that is no, you didn't count them. You can very quickly recognize and make a good guess as to which one had more dots on it. That useful guess is called an estimate. We make useful guesses, estimates, all the time. As a matter of fact, we're surrounded with it. When we pull into the service station and we ask to have our oil checked, the person goes in, pulls out the dipstick, and there's no way for them to know exactly how much oil we have. But we very often hear them say, you know, the next time you come in, you're going to need about a quart of oil. About 1 quart. That's an example of an estimate. In the fall, the leaves on this tree are going to turn colors, and then the leaves are going to fall to the ground. Now, we don't need to know exactly how many leaves are on our lawn. More than likely, though, we are going to need to know how long is it going to take us to get them off of our lawn. And so we'll make an estimate. We won't say something like, well, it'll take us 1 hour and 23 minutes to rake up all these leaves. We're more than likely to say, oh, between 1 hour and 2 hours, and I'll be done with that job. Estimation, something that we do all the time. We often say, well, it's nearly 30 miles from this town to the next, or it's about 15 minutes until the train arrives. How many times have you reached into your pocket and pulled out some change and said, well, let's see, that's less than $1. That's an example of an estimate. Estimation is a very important mathematical skill. Why? Well, you may now recognize that almost every number that you use is an estimate of one form or another. It's rare for us to have to use an exact amount of anything. There's one more point we need to make about estimation, and that's the point about accuracy. If we were to look at the United States from the East Coast to the West Coast, we know that it's about 3,000 miles. Now, if we estimated it to be 3,100 miles or 2,900 miles, those would be good estimates, even though we were maybe off by 100 miles. If we, on the other hand, wanted to find out how far it was across town, and we made an estimate that was off by 100 miles, we would have a very bad error. The point here is this. When you're making an estimate, it only becomes a good estimate when you're in the right situation. Estimation, two important things. One, it is nothing more than a useful guess and something that we use on a continual basis. And two, the accuracy of your estimate depends upon the situation in which you are placing the estimate upon. Estimation is something that we use every day. It's a life skill that we need to practice and get good at.
This couple wants to know how long it will take them to get from the rest stop to their friend's house several miles away. This is actually a problem of knowing how to estimate, and there are many different ways that we can do this. Today we're going to talk about 3. One way to estimate is to use the first number or leftmost digit in the numbers that we're dealing with. Let me show you what I'm talking about. Let's say I'm standing in the grocery line with these 2 products that I want to buy, and I don't know if I've got enough money to pay for them. Well, by looking at the first number or the dollar value in each price, I may be able to get a pretty good idea. Let's see, this one costs $3.19, and this one at $1.29. 3 and 1, $3 and $1 can be quickly added together and give me a value of $4 that I can expect to spend. Another way to estimate would be to use rounding off, and it's a method that I'm sure you use all the time. To illustrate, I'll use this piece of a number line that I have here. I've got a value of 386, and I want to find out what number it's closest to. Well, is it closer to 300, 350, or 400? On a number line, 386 would probably be about right here. So I can see that I can round up to 400 if I so choose. But we don't always round up. Sometimes we round down. An example of that might be in trying to determine body weight. I'm standing on my bathroom scale, and I notice that it reads 152 pounds and some ounces. Well, if anyone asks me how much I weigh, I'm not likely to say 152 pounds and some ounces. I would more than likely round down to 150 pounds instead. Still, another way to estimate would be to use a method that I call grouping or clustering. I'm going to use my electric bill to give you an example of what I mean. I want to know how much I need to set aside in my budget each month to pay for the amount of electricity I use. I've noticed that over several different months my bill has come in at $44 one month, $47 at another time, $43, even $42. Instead of adding up these 4 numbers and dividing to get an average, I might look at them closely and notice that they all cluster or group around a single value of about $45 a month. So that's how much I decide that I should set aside. Now let's go back to our couple at the rest stop and their problem of how to get to their destination and how long it's going to take. From the map, they notice that they've got about 246 miles left to go. But that number would be difficult to use, so they round up to 250 as we did with the number line and the example of the body weight. The speed limit is posted at 65 miles an hour, but they plan to make at least 2 more stops, and they know that the traffic is likely to fluctuate. And over a period of time, they probably won't drive a constant 65, but maybe 40 or 50 instead. So looking at the different range of speeds that they'll be driving, they decide that the values seem to cluster or group around about 50 miles an hour. So with 50 miles an hour as their average speed and 250 miles that they have left to go, they can simply divide 50 into 250 and come up with 5 hours before they reach their friends. Today we've talked about 3 different ways that we can estimate. We talked about using the first number, we talked about rounding, and we used an example of grouping or clustering. But the most important thing we did is we showed how you can combine 2 ways to estimate to solve one problem.
Columbus was right back in 1492 in thinking that the world was round. But his estimate of the size of the Earth was way off. The Earth is about twice as big as Columbus thought in 1492. And that's strange, because way back in the 3rd century BC, a Greek geographer named Eratosthenes came up with an estimate of the size of the Earth that is almost exactly right.
Estimation is valuable because sometimes it can give us an approximate answer when there's no way to figure the exact answer. For example, how much does the Earth weigh at this many kilograms? We don't know the Earth's weight exactly, of course. Scientists estimate it. Another reason to estimate is that it's quick and convenient. The scale is not exact. It doesn't have to be to do the job. Finally, estimation is valuable because it helps us avoid mistakes. That can't be right. That's better.
We have the best Mexican food this side of Santa Monica. Generally, when we get ready for our weekend rush, we make sure that we order enough food by estimating that we'll have at least 1,000 to 1,200 people come through the restaurant. We generally start off by 150 pounds of beans. We buy 80 pounds of chicken, 100 pounds of hamburger, and several cases of flour and corn tortillas. Our rice we buy 100-pound bags because we don't have to make it all at one time. We can stop and make 15 pounds at a time. That way that there's no waste.
I'm a geologist, and I'm trying to find out whether this is a good site for a groundwater well for a family. I've got a map of the area, and it looks like, since we're up so high, that the limiting factor might be how much they want to spend on drilling deep, because it's probably going to be farther to groundwater up here. This map shows that we're at about 1,000 feet in elevation, and so that's about 90 feet above the stream down below. And that surface water down there shows at about the level that groundwater is going to be right underneath us here. So if groundwater is about 90 feet down, the owners are going to have to drill at least 90 feet to get any groundwater. If they were to drill about 100 feet, they'd get 10 feet of water in their well. And that's not enough for a family. You'd want about 70 or 75 feet of water in a well. And so 90 feet down plus 75 feet further into water is about 165 feet in depth. So they're going to have to drill about 165 feet here to get enough water to provide water for their family on this site. Now that's going to be deeper than most of their neighbors will have had to drill.
I milk 30 cows, and thank God, and because of the early spring and all the grass that we have now, my operation is doing great, real good. As you can see, I got the cows here ready to go in the dairy, and I milk twice a day. I milk in the morning and also in the afternoon. And the production of the cows, usually I get an average of 5 gallons of milk out of each one of these cows in the morning. And in the afternoon milking, it'll be about one gallon less. It'll be about 4 gallons per each one of the cows.